So we started our discussion about absolute value inequalities yesterday with focusing on the and absolute value inequalities. Now remember, with an absolute value inequality, we're still going to get the two results. The only thing is they're not going to be two solutions like we get with an absolute value equation. What we're going to be establishing when we break things into the two parts is a compound inequality, and we're therefore going to be establishing our boundaries. With an and inequality, that those boundaries are going to essentially be the endpoints, whether those be open or closed, of a line segment that we're going to graph. But with an or compound inequality, they're going to be the endpoints or the starting points, I guess we could say, of the oars or of the rays that we're going to be drawing. Remember those oars of the boat, okay? So I feel like we have a pretty good understanding of and compound inequalities already. So what we're going to do is move on to seeing what an or compound inequality or an or absolute value inequality looks like. So first of all, let's remember that we know already that when we deal with absolute value, the first step we need to do always is to isolate. Now that does not change. We have to isolate the absolute value expression. So whatever is going on outside those bars, we need to use inverse operations and get the bars all by themselves. Once we do that, we can visualize the absolute value expression as being some distance from zero. And by visualizing it, we need to anticipate that that absolute value being some distance from zero can either be some distance to the right or some distance to the left of zero. And we saw that with the and statements that we solved in the last lesson. When solving absolute value inequalities, as we've already talked about, this will result in setting up and solving some sort of compound inequality. So we're either going, so what we dealt with yesterday was solving for an and what we're dealing with today is solving for an or. And we're going to talk more in class about how to look at the inequality to determine whether it's an and or an or. But for now, everything we did in the previous lesson was an and. Everything we're doing today is an or. So we want to follow the same steps that we've grown used to with absolute value. We first want to see, is it isolated? Is it isolated? So I'm just going to write that over here. Is it isolated? It clearly is. I can see that this is all by itself. It's isolated. So we're good to go. Now what we're going to do is to create an or compound inequality. And I know that because I have that symbol right there. That type of symbol is always going to lead to setting up an or compound inequality. So we need to figure out how to do that. And it's somewhat similar to setting up an absolute value equation. So the first thing we're going to do, since we're isolated, is we're going to take that expression and break it into two. This is beginning to look like we're getting ready to solve for two equations as we would an absolute value equation, okay? Now what I like to do on the right side is just essentially take this symbol, greater than or equal to, and take that value 11, and that's going to become 1/2 of my or statement. On the other side, what we're going to have to do is flip that inequality symbol around. So it's not going to say greater than or equal to, it's going to say less than or equal to, and it's not going to say 11, it's going to say -11. So let me show you on a graph why that makes sense. So here's our number line. There's 0. And what we're saying is we have to be, whatever this is, it has to be at least 11 away from 0. So if we work to the right of 0, at least 11 away starts at 11 and moves to the right. So that would take care of this x minus 7 is greater than or equal to 11. That takes care of this piece. But taking into consideration the other side of 0, this absolute value can also be at least 11 away from 0 on the left, which means it's at least at negative 11 and then extending off from there to the left. So in this case, we'd be looking at x minus 7. Think about being to the left of negative 11 means that we're less than or equal to negative 11. So that takes care of this piece. So that's why we're getting this splitting into two, where we essentially rewrite our expression or rewrite our inequality without the bars, making up the right side. But over here, we're going to do what I call flip the sign. So I'm going to highlight this in green or rewrite this in green because we're going to, or I guess we're going to say we're going to flip the symbol. And I'm going to highlight that in blue. We're going to flip the sign. What that means when we write the left side of our or statement to acknowledge that it's running away to the left of some value, we have to say it's less than or equal to, depending upon the inequality, some negative value. So if we can comprehend this, then the next step is going to be pretty straightforward because we built our or statement. Now we can just move forward with solving for each. We add 7 to both sides on one part, we add 7 to both sides on the other. What we're going to get is x is less than or equal to negative 4, or x is greater than or equal to 18. Those are the values that, if I substitute in for x, would make the absolute value of all of this at least 11 away from 0. So if we talk through it, let's see, negative 4 minus 7 is negative 11. The absolute value of negative 11 is 11. Is that greater than or equal to 11? Yes, it is. So we know that is a correct solution. We can test 18. 18 minus 7 is 11. The absolute value of 11 is 11. That is greater than or equal to 11, as the original inequality says as well. So the only thing that's left to do is to graph this. And this graphs as we are accustomed to. Here's our number line. We have 0, negative 4, 18. We have a closed dot in both cases, and we have our oars of the boat. So by the time we're done, our solution is x is less than or equal to negative 4. Don't forget the word or, it's an or statement, or x is greater than or equal to 18 in the graph that goes with it. So let's do one more together, because this one will require isolating, and we'll see if we can get a little more comfortable with breaking it into the or statement from there. So first thing we'll want to do is obviously subtract 3, and I get 4, absolute value x minus 2 is greater than 24. I'll divide everything by 4, and now that I'm isolated, I'm going to move this over just a little bit. I'm going to get absolute value of x minus 2 is greater than 6. So again, we'll get into more discussion about this, but I know for sure this is an or statement. So let's see if we can a little more efficiently break this into our or statement. We're going to take the x minus 2 and rewrite it twice outside of the bars. On the right side, I just like to say it's greater than 6, which is just taking care of this. On the other side, we're going to flip the symbol. It's going to be less than, and we're going to flip the sign, so it's not going to be positive 6, it's going to be negative 6. So that's my flip the symbol. Instead of saying greater than, we say less than. We flip the sign. Instead of saying positive 6, we say negative 6. And don't forget the word or. This is an or statement. Now take it through from there. Add your 2 to both sides in one case. Add your 2 to the other side in the other case. X is less than negative 4. Or, don't forget, x is greater than 8. The only thing left to do is to graph. And since I think I'm running out of space, yep, I'll just move my graph over to the side here. I have 0. I have my -4, that's 1/2 of my OR solution with an open dot. I have +8, that's the other half of my OR solution with an open dot. And I have my rays running away from each other. Okay, so the key for you in all of this, as you do a group of problems on the other side, is to remember this whole idea of flip the sign, flip the symbol. And that's most important when we're talking about this piece on the left side of the OR statement that we do. So work through that. Again, you have your notes. You have this video to refer back to as much as you need to help you to successfully work through the next 4 problems. We'll see you in class.